morning everyone. Myself M.Surekha, lecturer in physics, PR Government College, Autonomous Kakinada. We will discuss LR circuit in this presentation. Before going to our topic, we will discuss about what are learning objectives, learning outcomes, and prerequisites. Learning objectives are describe the relation between the current and voltage in LR circuit, determine the impedance and phase angle in series LR circuit. The impedance of LR circuit is determined by resistance and inductance XL. The impedance is denoted with Z. In case of pure resistance, the phase angle between voltage and current is 0. In case of pure inductance, the angle in the current and voltage is 90. If it is a LR circuit, is the combination of inductance and resistance, then the phase angle between the current and voltage is in between 0 to 90. Learning outcomes. The LR circuit are used in DC power to radio frequency amplifiers where the inductor is used to pass DC bias current and blocks the RF returning back into the power supply. Communication systems, and this LR circuit also used in radio wave transmitters, oscillator circuit, RF amplifiers, filter circuits, variable tune circuits, and magnification of current and voltage, etc. Next, prerequisites. Before going to our topic, which parameters we have to know are nothing but prerequisites. What is resistance? Resistance is the measure of opposition to current flow, and reactance X, opposition that the electric components exhibit to pass the AC resist current without dissipating power, unlike resistance. In case of resistance, the opposition of current flow. Resistance is the measure of opposition to current flow. Reactance is the opposition to change in the current. That is, when we passing the AC current, it resists the AC current. That is change. It opposes the change in the current. The two reactance, in this reactance there is no power dissipation, whereas in case of resistance there is a power dissipation. Next, impedance. The effective resistance of electric circuit arising from combined effects of ohmic resistance and reactance. That is, impedance is the combined effect of resistance R and reactance Z, reactance X. This combined effect is nothing but impedance Z. Next, what is about phase angle? Phase angle is the difference between the electric current and the source voltage. It is the angle between the current and voltage, source voltage. Ohm's law. Ohm's law states that the voltage across the conductor is directly proportional to the current flowing through it, provided all physical conditions, that is temperature, remains constant. Mathematically, we already know that V is equal to IR, where V is the voltage, I is the current, R is the resistance. This is the relation between current and voltage. V is equal to IR. These are the prerequisites we have to first know before going to our topic. Our topic is AC circuit containing resistance and inductance. LR circuit. An LR circuit is a circuit consisting of passive components like resistance and inductor connected together, driven by the current source or voltage source. Here, resistance and inductors are passive components. These are connected in series, and the power supply is current source or voltage source. Here, voltage source E is equal to E naught sin omega t. Circuit containing resistance, inductance in series connected to source of EMF is equal to E naught sin omega t. Next, what is resistance? We already know that resistance is the measure of opposition to current flow. Next, inductance L, the circuit containing resistance and inductance. What is resistance? You already know. What is inductance? It is the current production in the coil due to the change in the magnetic flux. This is from Faraday's law. If there is a change in the magnetic flux, there is a production of EMF, that is current production in the coil due to the change in the magnetic flux. Due to the change in the current, an induced EMF is set up in the inductance which opposes the applied EMF and is given by minus L into di by dt. Okay, this is induced EMF. The induced EMF is equal to minus L into di by dt. Why you are using a negative sign? It opposes the change in the current flow. This is already we know that from the Lenz's law. Now, the effective EMF driving the current in the circuit will be E effective is equal to E naught sin omega t, that is applied voltage, minus L into di by dt, that is back EMF, that is opposes the applied EMF. So we denote here as total effective EMF E is equal to E effective is equal to E naught sin omega t minus L into di by dt. According to Ohm's law, this must be equal to IR. Okay, V is equal to IR. So E naught sin omega t minus L into di by dt is equal to IR. So this equation can be written as L into di by dt plus IR is equal to E naught sin omega t. In AC, that is alternating current, the current varies simple harmonically with the same frequency as the applied EMF, but differing in the amplitude and phase. So, trial solution of equation 1 may be given as I is equal to I naught sin omega t. Okay, EMF E is equal to E naught sin omega t. I is equal to I naught sin omega t minus phi. Here phi is the phase angle difference between voltage and total current, applied voltage and total current. So I naught is the maximum current and phi is the phase difference between the applied EMF and the total current. In order to obtain the values of these constants, we differentiate equation 2 with respect to time. So di by dt is equal to I naught omega cos omega t minus phi. Again differentiate. So then we get, substitute these values in this equation 1, that is L into di by dt plus IR is equal to E naught sin omega t. Substitute values of di by dt and I in this equation 1, then we get L I naught omega cos omega t minus phi plus R I naught sin omega t minus phi is equal to E naught sin omega t. Now we can write omega t as omega t minus phi plus phi. Same equation, L I naught omega cos omega t minus phi plus R I naught sin omega t minus phi is equal to E naught sin omega t minus phi plus phi. This omega t can be written as omega t minus phi plus phi. So expand this equation as sin A plus B. This take it as A plus B. Sin A plus B formula we have to use here. So from expansion we get E naught into sin A cos B, that is sin omega t cos phi plus E naught into cos omega t minus phi. This is equation 2. In this equation it is true for all values of t. So we compare the coefficient of sin omega t plus phi and cos omega t plus phi on both sides of this equation 2. Hence, equating the coefficients of sin omega t plus phi and cos omega t plus phi on both sides of equation 2, we get compare the coefficient of cos omega t plus phi. Here where it is cos omega t minus phi coefficient is Li naught omega. After equal to, we get the cos omega t minus phi term coefficient as E naught into sin phi. So this is the equation. After that we compare the coefficient of sin omega t minus phi. Okay, here sin omega t minus phi coefficient is R I naught. Again sin omega t minus phi coefficient is E naught cos phi. Compare these coefficients, we get the another equation as R I naught is equal to E naught cos phi. This is equation 3 and this is equation 4. Squaring and adding these two equations, we get E naught square sin square theta plus E naught square cos square theta is equal to L I naught omega whole square plus R I naught whole square. From this, E naught square, E naught square is equal to I naught square into R square plus L square omega square. This is the equation. So from this we can calculate the I naught square is equal to E naught square by R square plus L square omega square. Amplitude of the current I naught can be written root on both sides, then we get I naught is equal to E naught by root of R square plus L square omega square. Dividing equation 3 and 4, then we get sin phi by cos phi is equal to L omega by R, that is tan phi is equal to omega L by R. Here phi is the phase angle. Phi nothing but tan inverse L omega by R. Current here, phi angle denotes the current lags in phase behind the EMF by an angle. Phi. Phi is equal to tan inverse omega L by R, that is tan inverse XL by R. So I is equal to I naught sine omega t minus phi. Here I naught value is E naught by root of R square plus L square omega square sine omega t minus phi. Next, impedance. What is impedance? Impedance Z is equal to current by voltage by current. And V is equal to IR. V is equal to IR. So R is equal to V by I. Here impedance Z. Z, why you call it as impedance? It is the combined effect of resistance and inductance, reactance. Combined effect of resistance and reactance is nothing but impedance. Z is equal to E naught by I naught. From this we can get the value of Z as root of R square plus L square omega square, that is Z is equal to root of R square plus XL square. Here it is a Z. Here I naught is equal to E naught by Z. I naught is equal to E naught by Z, where Z is equal to root of R square plus L square omega square. Z is equal to root of R square plus L square omega square. So Z is equal to root of R square plus L omega is nothing but XL. So root of R square plus L square omega square. Vector diagram of LR circuit. The impedance of series LR circuit is nothing but the combined effect of resistance and reactance. Here we use the inductance, so it is the inductive reactance, that is R and XL of the circuit as a whole. So impedance Z is equal to root of R square plus XL square. Here we denote the R and XL. They are 90 degrees apart from each other. When we consider the pure resistance, then phase angle between the current and voltage is 0. When we consider the pure inductance, the phase angle between the current and voltage is 90. When we take the both R and L, that is resistance and inductive reactance, the phase angle is in between 0 to 90. So Z is the combined effect of these two, so that we can denote it as this is R, this is XL, this is Z. According to Pythagoras theorem, Z square is equal to R square plus XL square. Z square is equal to R square plus XL square. From this we can calculate the Z as root of R square plus XL square. In terms of voltage, ER is nothing but IR. This is resistance, this is XL. So both multiplied with current, I into R is ER, I into XL is EL. The combined effect of both is E total. So Z is equal to, already know that Z is equal to root of R square plus XL square. IZ multiplied with current, then we get root of IR whole square plus IXL whole square, that is ET is equal to total EMF ET is equal to root of ER square plus EL square. So here in case of pure resistive circuit, only pure resistance, then the phase angle between the current and voltage is 0. In case of pure inductance circuit, the phase angle is between the current and voltage is 90. Here, current lags behind the voltage by 90. But when we take the combined effect of both, that is resistance and inductor, the phase angle between in LR series LR circuit is in between 0 to 90. Here this angle theta is not 0 and neither 0 nor 90, it is in between 0 to 90. So here angle theta is the phase angle, cos phi denotes the power factor is denoted by cos phi. So cos phi from this triangle, cos phi is adjacent side by hypotenuse, that is ER by ET. So ER is nothing but IR and ET is nothing but IZ. From this cos theta is equal to R by Z. Here cos theta nothing but power factor. So power in LR circuit. Power is, we already know that power is nothing but voltage, product of voltage and current and phase angle, power factor. So V into I into cos phi. Here V is total EMF, ET into total current, I into cos phi. Substitute ET as IZ. So IZ into I into cos phi is R by Z. Substitute this, Z will be cancelled, that is impedance will be cancelled, then we get I square R. Power is equal to I square R. From this equation we conclude that the inductor does not consumes any power to the circuit. Thank you. Thank you for giving this opportunity.